Yeah, and I mean, my biggest thing is like, you've talked about networks quite a bit, or like you hear DDoS all the time, and people will talk about it without knowing what a DDoS or denial of service attack actually is. And it's hard to know, like you said, the effects that denial of service attack could have on a network or a site without even knowing what a network really is. Or it's kind of weird because like when I got into my profession of like working in networking and stuff, you don't really you don't even realize that like no one really knows how the internet works even, and you just use it on a daily. And it's something that's like pretty new, that's been about probably since like 95 that the internet's been really a thing that's public. I think it came out in like 1992 that for public use or
Yeah,
around
something
there.
like that. Yeah, the for me, the internet or computers are a magic box in which I turn it on, and then the magic turns on the screens, and then the magic also allows me to talk over voice to you like this. I have very, very little knowledge. I could probably give you like a preschooler's explanation of what the internet is, but when it comes to anything in detail, I don't know.
And so like I could either do two things. One is like I did create like a whole thing that like shows off like the stages of how network got formed, like the history of the internet. And then we could go off into like a network diagram where it just shows off like a basic idea of like how something like Twitter could function.
Yeah,
Or you could just ask a bunch of questions and I can just answer them about something like DDoS attacks. It's just gonna be a lot easier if I like use a diagram which I
yeah.
created to
I think
explain
that
that type of
the
stuff.
I think that like the problem with me asking you questions is that uh, it's one of those like unknown unknowns. I don't even know what to ask in regards to any of this. So like, yeah, show me your diagrams, my guy.
Look at that. So long story short, just gonna go over a few things. When networks first really started kicking off, it was the era of the telegraph. Really, the telegraph was really important because it kind of created this idea of binary where you could do like little click sounds or pulses.
Well, that
And
one
the
I
difference
don't
between
know.
the pulses uh, can send a signal. So essentially, like and
Dot
when we
dot
say like
dash.
binary, you can have like something that has two different states, like a high and a low. So like with fiber optics, you've got like a laser. The laser can be on or off. And then with those pulses, you can then transform that into some form of data.
Mhm.
Then we get down to like the beginning of it all, where computers were first starting, and the US had a job called a computer, and it was just rows and rows of women during the world wars. And like literally, the Atlantic even has an article from 2013. Computing power used to be measured in kilogirls, thousands of women.
Binders full of women, in fact.
Binders. And so it's always funny when people talk about how technology's taken our jobs. Because, well, they're complaining on a device that took factories of women that were doing math to figure out how a mortar shell gets lobbed out of a cannon. And so the soldiers on the front lines can shoot their mortars.
Mhm.
Which then comes to the first computer, broke the Enigma machine. Wonderful, who cares? Because that's where you get to stage one of networking, which is the computer, which is essentially you have to have something on the computer that can distribute files or data, because you might have an application like Discord, Skype, or something else. And that application, um, essentially the computer has to decide which application that data it receives gets.
Right.
Which then we get to the next level that someone created of networking that took in the 1960s. You ready for this?
Mhm.
They figured out
Two.
that you can string a cable between two computers. I know, it's insane. But this is what really started the idea of what's called MAC addresses. MAC addresses, every computer has their own specific address. It's like a social security number.
Mhm.
Essentially, Just like a social, you can type it in, and that is your specific device. There is no computer in the world, camera, whatever, that can connect to a network that has your number.
Okay.
Which then we get to stage 3. And so this started taking off where they had something called vampire cables where they could link all the computers together. And then they ran into an issue, which is you can only link so many computers together to a single wire because one computer would have to take over that wire to use it at a time.
Okay. So it kind of like in like layman's terms, it would be like a traffic jam. Like this guy's got to go through, and then now this guy can go through, and now this guy can go through.
Yeah, so literally what happened is this guy wants to send an email to this guy, and this guy wants to send an email to this guy.
Mm-hmm.
Well, this guy, his computer would say, I'm taking over this wire, and while it's doing that, this guy looks at the wire, and it goes, I can't send the email, it's in use. So the computer would go into sleep for a random amount of time, and it would wake up and see if this wire is still being used. If not, then it would send the email. And you could see, like, if you had enough computers on there, they would just always be going into sleep, and it would just get slower and slower until it basically ceases functioning.
Mm-hmm.
So, some smart guy came up with this device, which is the first of the major networking devices that stopped us from just hooking computers up to, well, literally back up here, they would have something where they would just nail the computer, I'm not kidding you, a hammer and nail, into a giant thick copper cable. And so they stopped doing that, and they created what's called a network switch. And so this device could send a piece of data called a packet out. It would hit the switch, and that packet would say, I want to be sent to this computer. And it's like the switch would go, sends to this computer, and then that packet also had where it was being sent from. Basically works exactly like the post office,
Okay.
with a to and from address. And then if you wanted to reply back, it would just send it back. And so multiple devices could work at the same time because this thing was switching them all.
Gotcha.
Then we got to the next stage, which is, okay, now...
We're going to hook up multiple of these together.
Exactly, because this thing can only switch so many devices on a packet at once. So you just link another one. And so what you see a lot is like in office buildings or in your apartment, you'll have multiple of these things linked up so they could connect to the outlets in your house, and then you can connect your PC or other devices to them.
Okay.
We enter stage 6.
This is where it starts getting complicated.
And we add what's called a router.
Okay.
So essentially what a router does is we figured out that you can link multiple computers together on a floor to a router. And so like we could have 2 floors going. But if you wanted to send data outside to a building or something, you really couldn't do that too easily. So this allowed you to send data long distance.
So this is
So
like post floppy disk era. You would, like before, you would have to like put it onto a physical item and then move that item into the other computer to transfer the data. Whereas now we have the routers, you can just send that data instead of having to put it onto a physical item. Yeah.
Yeah. So at the first stage, this was like around the 1950s.
Okay.
And this was like UCA Berkeley, their computer science lab or their computer science building, like their whole engineering building was all linked together at this stage. But UCA Berkeley wanted to be able to talk to another college. So they created this to allow them to talk to another college. Which this stage then formed what's called ARPANET because the US government and military got more involved. And essentially, this was far enough along now where like they could even link military bases together.
Okay.
If that makes sense.
Yeah.
So, we get to one final stage though, because essentially when you're linking colleges together, you're not too worried about viruses or someone sending bad data or like hurting each other or DDoS attacking each other or doing fun stuff. But once you start involving people that are outside of like the college or like the small group of colleges and you add on military and stuff, you start getting really worried. So then you add what's called firewalls to it, which then you can have one institution protected by a firewall, and then there's like a centralized router that can then send data to another institution that's also protected by their own firewall. And the firewall is what stops all the data from coming, or can stop data from coming in and out. So when people talk about like they're blocking someone's IP address, they go into this firewall and they literally just say anyone being sent from this company can no longer send data.
Okay, I got you.
Which then eventually builds this whole idea.
So we would have multiple of the things up above. Like each one of these boxes would be like one of the diagrams above, and then they're connected by a router, yeah?
Yep.
Okay, cool.
And it's like this router is like for a whole entire area. So like this could be California, this could be Washington, this could be Colorado.
Okay.
And then the other thing that this brought in is sometimes a router might get overwhelmed with traffic. So they created something that you actually use a lot in Google Maps or in video games, which is like they call it OSPF, Open Shortest Path First. Essentially, like when you're driving your car, you're going across a road, and so like normally Google Maps will take you the shortest distance, right?
Yeah.
Well, there's a problem, like maybe there's a car accident right here. This is no longer the fastest distance, even though it's the shortest. So the routers all detect that, and then it starts passing data around it all.
So the problem that we had before with the copper wire in the wall nailed to it with a nail, we started running into that kind of a little bit the more complex that these networks became. So we created ways to kind of like bypass traffic to ease the load on specific routers, yeah?
Well, sort of. I mean, yeah, you are right. Actually,
I'm
no,
giving
you're
it like the
absolutely right.
super layman's way of understanding it. I think I'm understanding it, but I'm just like giving
Yeah,
like the
so like
easiest way to explain it for me.
to say it like this, which I think you're actually right on the money. This line right here can only transfer like let's say 1,000 packets a second. Well, you can imagine you can have so many PCs hooked up that it overwhelms this line. So the best thing to do is to create a shit show that connects multiple lines together, so that way they can go around each other if they need to.
Okay.
Which is why we call it like the web, is because it makes a web.
Okay. I got you.
And by this point, we reached 1969, or 1982. I mean, sorry, where you can see 1969 was when we were in that first couple stages where you had like, you didn't really have much, and then by 1982, military bases and all the universities were connected.
Okay. I didn't realize that we had this like level of infrastructure around it by that time.
Yeah, and still by that time, it was still ARPANET, so it was still a military slash scientific endeavor. So it was only really the military or colleges, like the state colleges, could really use it. We
Okay.
had a few private colleges, but like it was all underneath the goal of ARPANET, which the goal of ARPANET was decentralized communication, resource sharing, research and development, readability and redundancy, interconnectivity, and scalability. So essentially, it had both the idea of like you can now instantly send your research data to each other instead of having to wait by mail. And the other thing is since this was the height of the Cold War, if a node got taken out by like a nuclear weapon, could the whole system self-mend itself, like go around it? And with OSPF, if like this city went missing, everything could still go around.
Okay.
Which then caused the creation of the ICCB because there was a scandal that happened. You might know a nice little browser called Mozilla Firefox.
Oh shit.
They went public and started making money. And I think the lawsuits really started kicking off between them in like the 2000s-ish.
Okay.
But with the ICCB, it created all these laws on how the internet on how the internet functions. That allows it to function like today. So that's where you hear things like net neutrality, peering agreements, and all these other things. So essentially, all these laws really say is like between. You might have multiple people own different routers. They're not allowed to charge each other when data is going across their routers. And they have to allow all data through from one, or not all data, but they have to allow like acceptable data, I guess is how I'd put it, through between one router to another.
Yeah,
It's like they can still block if someone does something illegal, like a DDoS attack, but they can't block you because you're from Idaho or something.
Okay.
Which, going all the way back up here, is where you get what a normal building would look like. Like this might be what your house looks like, where you've got your router, switch, and Wi-Fi. It's usually packaged into one device. And then your router can be connected to a computer, a phone, because now we do
digital calling instead of like direct analog type stuff.
Yeah, exactly. I'm forgetting the name off the top of my head what it's called. But yeah, it's everything now uses the internet, including cable companies.
Okay.
So with this, if you build this out even more, you get to the point of an organization where the organization might have multiple routers. Okay. And in a building, and this might be a server room, this might be their offices, and then they've got Wi-Fi. Into them having more buildings that they can connect their routing to, so this becomes a campus. And then you also have a firewall that can then lead out to Spectrum, which is your service provider. So then you can have Spectrum link up to Blue Peak. Blue Peak might link to AT&T, where you can get your cell phone signal, or Verizon. Or you can go all the way down here, and you can see that there's some more buildings connected, and so forth. And it's like all of this is really like how the very, very basics and like a very, very broad stroke, how the internet works.
Okay. This is actually like incredibly easy to understand with the diagrams that you made. This is like pretty cool. All right.
Thanks. It took me an hour.
Well, it's definitely doing the job. I definitely do understand what's going on, like in terms of like how everything's connected and all of that. So when we get to like a DDoS attack, so walk me through on this, how like a DDoS attack might attack a website, and then if it's possible, how they would attack a specific like function of that website or a specific like page on that website.
Yeah, so let's go like you're talking about like streaming, for instance, right?
Yeah.
So this building, we'll rename it to Song Soul's House.
Okay.
And so you're streaming, it goes to your router, and then it goes out to the internet. Mm-hmm. Like I have government lines here, but you might have it going out to Spectrum or whoever. And then this might be Twitter. Now the only difference is Twitter might look more like this, because since it's a big company, they might have, something like that going on. Mm-hmm. So if I was going to DDoS attack, I could try to DDoS attack Twitter, which might have multiple ways into their facilities from their firewalls. And so it might be hard for me to shut down one single node. And so what I might do is, well, you've got like a node to your house. You only have one way to enter your house. And basically routers can only route so much traffic per second. So many packets per second. Yeah, and so you also have like a lower.
A DDoS attack usually involves like a network of computers all sending packets of data all at the same time. Like, and it's usually junk data, but it's just to overwhelm a specific node.
Yeah, do they have an X in here?
I have no idea what you're using.
You know what? We're just going to do this. This is the X symbol, because I'm not going to look that hard.
Okay.
So they might DDoS attack and block your router from here.
Okay.
So, if you notice, now you don't really have a way to get out to the internet anymore. That means that your stream shuts down. But Twitter's not, or well, if you're streaming on Twitter, Twitter's not shut down. Their lines are completely open. It's just your lines that they've blocked now.
Right.
So now you've got two options, really. You can either wait for it to be over or reside because it's intensive thing. You basically have to have a machine constantly spamming trash to you to bog down your router till it is only really receiving trash and not being able to send out the data that you want. Or you might go, hey, this guy is DDoS attacking me from one single IP. So you could go to your firewall because you've got one, and you can, or your router because it also has basic functions, and you can say block all traffic from this thing. And so every time it gets a packet that says I'm from this person, it just throws it away, which then reopens up your lanes.
Okay.
So that's why when you hear people do DDoS attacks, you'll always hear that they're sending it from multiple sources.
Okay, so it's not that one computer can't DDoS attack, but it's easy to stop someone from DDoSing attack from one computer. If you want like an actually effective DDoS, you have to flood from multiple places, so it's harder for them to isolate and cut out that IP address.
Exactly. And then it makes it even harder because if you have enough computers, they might not have to be sending out that many packets because you might need to only have 1,000 packets to be overwhelmed.
Mm-hmm.
And each computer, like let's say if they had 100 computers and they were just sending out 10 packets a second to you, that would be enough to overwhelm you. And so the problem is like, yes, your router's seeing the data, but the data is encrypted still, and it can't decrypt it, and all it can see is the to and from. So when you're using your computer, which data is the DDoS attack, or which packets are the DDoS attack, and which packets are what you actually want through, it starts to become hard to tell.
Yeah. Okay. So how would it be possible? Because like based off of this, I don't understand how you could DDoS like a specific like Twitter space. Like, is
So
that
in this
even
case,
possible or?
you're talking about a stream. So that's why I
So
mentioned
that
that.
one stream. So in order for that to work, they would be targeting the computers of either Elon Musk or of Donald Trump, whoever was hosting the actual stream of the Twitter space. It wouldn't be
Yeah, and then
attacking the page. I understand.
this is where it all gets theoretical because if they're streaming from their house, it's going to look a lot more like this. If they're streaming from Twitter headquarters, it's going to have like multiple ways in and like be a lot more crazy. So it'd be a lot harder to because now you have to with just this alone,
Yeah, there's so many
you have
different
to shut
areas to
down 2
attack.
nodes.
Yeah. But when it comes to like the Twitter space, the one hosting it would probably be the one that you would DDoS. You wouldn't need to even attack like DDoS Twitter like itself. You could just DDoS Trump or you could DDoS Elon or whatever. Okay, I
Exactly.
understand.
And so you might have services like Cloudflare, where Cloudflare just does this. So they have a whole bunch of servers. One of these are holding your website, and you might be able to DDoS attack this server. But then they just do this. And they just duplicate the data.
And reroute it through somewhere else.
Yeah, and then this data is over here. So even if you're attacking, well, that stays a thin line. Even if you're attacking this cluster of servers, this cluster also has your website on it, and it's still active.
I got you.
Which is how more bigger organizations like Microsoft or Cloudflare or others can get around it too.
Okay, cool. Um, I can't. It is. I think you've literally answered every single question I could have thought of. Like the way that you presented it and the explanation is actually like really good. You should like never mind.
It's almost like if you knew, I'm not going to say much, but Sanzel knows enough about me that he knows why I'm pretty good with my explanations.
Yeah. All right.
Or Tron, with your serious question, it would not look like views because the DDoS attack is just meant to send crap. It's pointless data. Like it means nothing to the computer. It doesn't do anything. But because the routers can't see what the data is, because essentially, if you want to go really into it, you've got. Give me a second. So Cisco made something called the 7-layer OSI model, and let me full screen.
They are asking
Where?
if you think that Destiny was justified, morally justified to kill the DDoS kid.
No, I think the DDoS kid was very, very basic, and I think Destiny. Unfortunately, not a lot of people know how networks work, which is a shame because I think this is can be explained very easily. But really fast, answering Tron's question. So your computer has to go through all of these layers. So layer 7 is the application. Your computer has to decide which application it's going to. Then you've got your presentation where your computer encrypts the data. Session, your computer stores where the other computer where it's sending the data. Sorry, that was where it's sending the data. Transport is how it's sending the data. So this is your UDP or TCP. UDP is like a radio. TCP is like telephone. So like the cop radios where they have to say over so they don't talk over each other.
Yeah.
It's because their telephones or their radios only blast a signal, and then they'll receive a signal, but they don't tell each other if they've received a signal or not. And that's really important for things like this stream, because you're getting so many packets so fast. You don't want TCP, because what TCP will do is it'll go, wait a minute, I'm missing a packet, like I'm missing a frame of the stream. Stops the whole entire stream, tells Sanzel's computer, hey, I'm missing this bit of information, I need that really fast. Sanzel's computer sends it back, and then it gets it and then starts replaying the stream. That's where you get, for instance, in video games, that's where rubber banding comes from, because you're using TCP instead of UDP. Because it'll stop the game, even though your computer hasn't registered it. Ask the other computer, hey, I need where this character is supposed to be. The other computer sends it, and then it goes, okay, and it moves your character back and rubber bands you.
I got you.
Then the whole layer stuff that we're talking about, network layer, is the router, so that's where it sends it to each other. This is your switch, and then this is this is the wires, lasers, or however it's sending the data. And then it just goes right back up to the other computer.
Through the same means, yeah.
Mm-hmm. So it goes down and back up.
Okay, one person was asking about IP spoofing. I would assume that's like using an what do you call it, a VPN to like fake an IP address? Or is that something else?
An IP address is like your mailing address.
Yeah.
So let's say I assign a static IP, because you can it gets more complicated. But we're just going to say that we assign a static IP of like 63, 126, 82.
Bro, you're telling everyone what my IP is right now, dude. I want to get DDoS.
So this computer's got that. I could log in to this network, and I could say this laptop actually has this mailing address too.
Gotcha.
And then this switch is going to go, hey, this laptop connected, it's got this mailing address. And then when the switch receives a packet, it goes, okay, which mailing address do I need to send this packet to? And it goes, oh, I got to send it to this laptop. So then it suddenly starts sending all the data over to the laptop rather than to the server.
And I assume that there's like, it prioritizes based off of certain things because like they're both in connection with that router. So why does it choose the laptop over the server?
If
it's like super complicated, like we don't have to get into it, but like
it gets more complicated. I'm trying to keep things simple.
Yeah. Sorry.
But no, IP spoofing, yeah, it's just essentially you're making your IP address the same you're making your computer's mailing address the same mailing address as another computer. So then all the traffic you send goes, or basically it makes the whole network think that your computer is supposed to be the one that receives that traffic.
Okay, I got you. That would be good
And
for like
then,
trying to like steal someone's info or something like that.
yeah, exactly. Or you can see like what data they're receiving and stuff. Another common one that you might see or like hear people talk about is like a middleman attack. And essentially, someone takes over something like this wire right here. They put a device right in the middle, and then they have the device pass through the data between it and the router. It's like the data is unaffected, but the device sees all the data, even though it's still encrypted, and then it can just record it or do whatever. And if
Okay.
it's really good, because this device here has to know how to decrypt the data, one of the packets that they send out is the key. So if you catch the key, you can then encrypt or decrypt all the data that's going through. And so that's a man in the middle attack.
And that would involve like someone like physically going to a location and putting a device into like series with the other router or the other servers. You would just have to make it less noticeable.
This is the easiest one to explain, but if you remember, this is why I started off in like the 1800s.
Okay.
Because all mediums is just pulses. So the most common and easiest to explain medium is copper cables. But you've got your Wi-Fi.
Okay.
So you could just man the middle attack Wi-Fi. All it's got to do is just receive all the same data that like this one would receive.
Okay. Okay. I got you.
So or like you've got SpaceX, their satellites shoot laser pulses between each other. I was joking with Internet Gas on Discord about that. And so you could man the middle that too, where you get like a satellite in between the laser pulses, and then it just passes the pulse through, so like the network doesn't notice.
Is it true to protect from a DDoS attack you use DOS tools? That's
I
what they're
don't know
asking. I don't know what it
what do you
means.
mean by DOS tools?
Yeah, what does DOS tools mean? Gas.
Yeah, gas.
Piece of shit. You know
Isn't it
he's a
funny how like this stuff is complicated, but at the same time, like once it's explained, it kind of feels simple.
Yeah, no, it's one of those things like there are like of course like higher and lower levels of information, right? Like we give kindergartners like the lowest level of information that we can because it's just like building it up. And like this sort of thing would be a really good introductory course on or like just like a simple explainer on this for people that are mildly interested but may not need a whole bunch of information, or for people that are not like they need that baseline information to like build on it.
Yeah, I get that. Which is what, yeah, and like a lot of it's also, like you said, where you build up to it. Because if I just showed you this at the beginning, I think you would
Oh
have
yeah, I would
probably,
no clue what the you were talking about. I might be
your
able
mind
to
would like
like
explode.
suss out a little bit of it, but like in terms of what it actually is and what things are doing, I don't know if I would be able to suss that out. Well,
Yeah,
hurry up, gas. Sorry.
there's like one other thing while I'm waiting on gas
Mhm.
is like the reason why I draw squares around this, like this is like different areas, is because you'll notice if you've ever like set up a Minecraft server or something like that, you'll go, wait a minute, why is everyone's IP address 192.168.something.something? Everyone's. And here I am saying that the IP address is the mailing address of your device.
Mhm.
That's because once it goes out here to this one takes this IP address and it converts it over to one of theirs. So like this might be this might be the IP address that they assign you for your house. Once it hits your router might reassign it so that way it can use all these devices. So that way all these devices connect to it and everything's local.
Okay, I got you.
if that makes any sense.
All right, guess I'm giving you like 30 more seconds to enter your question. Let's see here, because so like as like a closing thing. Oh, well, guess finally message. Is there a way to block Starlink with basic jamming devices?
Yeah, so all a jamming device is you basically have to break you're trying to break the connection.
Mhm.
So with this copper cable, I might link another copper cable to it, and then I might just pump 5 volts through it. That 5 volts will read as always high, and then basically shuts down that line. For Wi-Fi, you might have a device that just constantly spams this wireless access point with just dumb data, and then it's unable to actually communicate with these devices or see what these devices are sending anymore. With Starlink, you would have to do something to. You can't really disrupt the light because the light is like, light passes through itself. So you would probably try to do something like shoot a laser beam into the detector of the other satellite, so that way the detector can't see the pulses anymore.
Okay, I gotcha. But that would but these are like actual satellites up in space, so that would be like a very high difficulty endeavor to do anything even remotely like that.
Yeah, you'd probably have a better shot just like if you detonate a nuclear weapon in space, nukes are EMPs, and you would just EMP all the satellites. So I'd probably just do that if we're talking about like World War III type events.
Yeah, I gotcha.
Which the US government did do, by the way. We did shoot a nuke into space. Not very many people know about that one.
Was it cool?
I guess so. It was kind of it was in that era where we're afraid of the Cold War, and we did a lot of like nuclear weapons stuff. Like there's the big Annie where we made a nuclear mortar. We made a nuclear
Oh yeah,
rocket
those
launcher.
little like tactical level nukes instead of like the strategic level.
And then we ran into that problem where we're like, how we stop Russian nukes, and we couldn't figure out a really good way. And then we went, wait a minute, what happens if we just nuke the Russian nukes?
Which is base. It's such an American way to think, you know? Like, these guys might be trying to blow us up, but what if we blow up their blow up things? That would be cool.
And it's like that scared the American public. So they actually released a video of like they made a bunch of military guys, and they did not tell the cameraman either. And the cameraman go out into the middle of a field, and they detonated a nuke above them just to show that it's safe to do.
Well, that's cool. Okay, little closing thoughts here. So, in your opinion on the claims that they were DDoSing Twitter over the Trump Elon conversation. Now, I even based off of everything here, I think that that's unlikely. It probably sounds like they just like overwhelmed the server because too many people were trying to listen at once. Yeah.
Yeah, so either one of two things happened. They either overwhelmed the server, or if they like were streaming at home, they could have like overwhelmed a router if someone knew Elon Musk's IP address to send a bunch of data to. Someone did like what that kid did to Destiny.
Gotcha.
So it could be one of those two things. The problem is, and that's why like when you started talking about it, I was like, and you asked me for quote answers, I was like, the problem is I don't know. I mean,
It's one of those
they
things that's just
really
like
wanted to.
it's hard to like provide evidence for it unless they like give us server health data during that time.
Yeah, and I also don't know why it's. I mean, I kind of get it because for right now, I don't know why this is the conservative talking line, but the whole point is like, we're so much more popular than you guys. Look at how many more views we got. We got so many that shut down, or Trump got so many views that literally shut down or shuttered Twitter's servers. Which, to me, that's kind of more of what it's leaning into. So I don't care necessarily, except for the fact that DDoS attacks are criminal. They happen on a daily. I got an email last night that someone tried DDoS attacking my org 4 times.
Jesus. So these are just like common things that people do.
Yeah, and I've seen people all over get shuttered by DDoS attacks if you get big enough of them. It's just the bigger the org, like something like Twitter. That's where you get into like what people are talking about with botnets, where like they install a piece of malware on your computer that's basically always asleep, and it just sends out like a few packets at a time, so you don't ever notice or care. But if they have that on like 50,000 computers, suddenly they can send 50,000 packets to your house.
Oh, okay. We're gonna need like a weekly lecture on like whatever. Anytime that there's some kind of cyber attack on something, we're gonna need you to explain what that is. Because I mean, like it's honestly it's super cool. It's super fascinating to listen to about it. But like I said in the Discord, like getting peaceful information like this is probably the best that I can do because I'm not going to go into a career on this, and I'm not going to get into many debates where we get into the nitty gritty on network stuff. Um, but like just like having that underlying knowledge, so like next time it comes up, I can understand what they're saying is happening.